Welcome to AI Explored. In this video, we will explore the fundamental concepts behind naive Bayes, including Bayes' theorem, probability and conditional probability, and how they all come together to form the naive Bayes algorithm. We will also take a look at the different types of naive Bayes classifiers and their unique features, as well as the various applications in real-world scenarios. By the end of this video, you'll have a solid understanding of naive Bayes and its practical uses in the world of data science. Bayes' theorem comes from 18th century mathematician Thomas Bayes, who proposed that the conditional probability of an event, based on the occurrence of another event, is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. The development of naive Bayes as a machine learning algorithm was greatly influenced by this theorem and was key in the development of the modern naive Bayes. To fully understand naive Bayes, it's essential to have a solid understanding of probability and conditional probability. Probability is the likelihood of an event occurring and is represented by a number between 0 and 1. Conditional probability is the probability of an event occurring given that another event has already occurred. It is represented by I/B, which means the probability of event I given that event B has occurred. Naive Bayes relies on the assumption that the variables are conditionally independent, which means that the occurrence of one feature does not affect the probability of another feature occurring. The algorithm is a simple and effective probabilistic classification algorithm that is based on Bayes' theorem. The algorithm assumes that the features or attributes of the data are conditionally independent of each other given the class, which is where the naive and naive Bayes comes from. This means that the algorithm assumes that the presence or absence of one feature has no effect on the presence or absence of another feature. The algorithm works by calculating the probability of each class, given the observed features of a data point, and selecting the class with the highest probability as the predicted class. This is done by multiplying the prior probability of the class with the conditional probability of each feature given the class, and then normalizing the result to obtain a probability distribution over all classes. Despite its simplicity and the naive assumption it makes, naive Bayes can perform surprisingly well on a wide range of classification tasks, and is often used as a baseline algorithm for comparison with more complex models. There are several types of naive Bayes algorithms, each suited for different types of data and classification tasks. The first type is Gaussian naive Bayes. It is used for continuous features and assumes that the data follows a normal distribution. This is often used for classification problems where the features are real-valued and continuous, such as predicting a person's income based on their age and education level. The second type is multinomial naive Bayes, which is used for discrete count data, such as word frequencies and text classification. It assumes that the data follows a multinomial distribution and is often used for natural language processing tasks, such as spam filtering and sentiment analysis. The third type is Bernoulli naive Bayes, which is similar to multinomial naive Bayes, but is used for binary or Boolean data, where the features can only take on two possible values, such as true or false. This is often used for text classification tasks, where the presence or absence of a certain word in a document is used as a feature. The choice of naive Bayes algorithm depends on the nature of the data and the specific classification task at hand. The algorithm has many real-world applications in various fields. Here are some examples of how it can be applied in real-world scenarios. Number 1. Spam filtering. Naive Bayes is commonly used for email spam filtering, where it can distinguish between spam and legitimate emails based on the words and phrases used in the email content. Number 2. Sentiment analysis. Naive Bayes can be used to classify the sentiment of text documents, such as social media posts or product reviews, as positive, negative, or neutral. This is useful for understanding customer opinions and preferences. Number 3. Medical diagnosis. Naive Bayes medical diagnosis by predicting the likelihood of a patient having a particular disease based on their symptoms and medical history. Number 4. Image recognition. Naive Bayes can be used for image recognition tasks, such as classifying images of animals or objects into different categories. Number 5. Fraud detection. Bayes can be used for fraud detection in financial transactions, such as credit card fraud, by analyzing patterns and identifying anomalies in the data. Overall, naive Bayes is a powerful and flexible algorithm that can be applied to a wide range of real-world problems, making it a valuable tool for data scientists and machine learning practitioners. If this video has helped you in any way, don't forget to like and subscribe. Comment down below what you'd like to see me do a video on next and click on the screen right now if you want to learn more about AI.